Okay, so in this video we're going to talk about population growth as an exponential function. So we have a word problem here. The next example would be another word problem. This is in 1996, the population of India was 952,108,100. It's growing at a rate of 1.3% each year. So we're going to use this idea to predict future populations in 2000 and 2010. So what multiplier is used to determine the population prediction? So we know that we're dealing with growth because it's growing at a rate of 1.3% each year. So the multiplier is going to be 100% plus 1.3%, which is going to give us the 101.3%. Convert it to a decimal by moving the decimal place over 2 spots. 1.013. Okay? And really, if you skip this step, that's fine. Just make sure that you're getting the correct decimal. Now we're going to write the exponential equation. And remember, we have our initial value with the multiplier raised to our exponent variable. So the initial value is 952,108,100 times, and I like putting the multiplier in parentheses, 1.013, all raised to the t for time. Okay, so we got our initial value, which is the 952 million. We have our multiplier, which we found in the first step, and then it's an exponential function with the exponent as our variable in this situation. And so now what we're going to do is we're going to go ahead and predict populations in 2000 and also in 2010. So we started in 1996. So 2000 is 4 years. So this is what t is going to equal. We started in 1996 to 2010, and that's going to be 14 years. Okay, so now we know what our variable is for each equation. So I'm going to set both up, and then we'll go ahead and we'll calculate those. So the first one, we're going to take our 952,108,100, and we're going to go ahead and set it up with our multiplier raised to the 4. Then we take out our calculator and do the calculation. Okay, so the commas didn't come out super great here, but I put them in red to distinguish between the commas. But we're looking at 1 billion people and wants us to round to the nearest 10,000ths. So the 10,000ths place, quick lesson, ones, tens, hundreds, thousands, 10,000ths. So it would be 1 billion, right? 2 million, 590,000. Okay, and we're going to set it up the same way for 2010. We got our initial value, got our multiplier, but to 14. Then we go ahead and plug in our calculator and crank it out. Okay, so we have in the year 2010, we're going to have 1,140,000,000. So large growth from the year 2000 to the year 2010. We'll go ahead and we'll round to the nearest 10,000ths place again. So we get 11408. This guy right here is our 10,000ths place. It's at 23, so we'd round down. And that would be our final answer, 1,140,820,000. And that's how we can use exponential growth to model. It's common in population, so it's a good example to use. What we're going to talk about is another population example. If we had a population in Tokyo and it's projected to grow at a rate of 1.1%, we're going to predict the population in the nearest 100,000, so be careful with the rounding, for the year 2010. So to go from 1995 to the year 2010 is a total of 15 years. I know my initial value is 28,447,000, and I know it's going to grow 1.1%. So 1.011 is my multiplier, and I just set up my growth statement. This inside right here, just to kind of discuss it, is 1 plus 0.011. This is our 100%, and this is our 1.1%. But just numerically looking at this, we see our initial plus our growth. Okay, so this guy right here is our initial, and this guy right here is our growth. So we're going to go ahead and pull out our calculator, crank out the numbers, and get an answer. Okay, so in this example, we end up with 33,519,984.31. So generally the rule of thumb is just to go ahead and round down, and I apologize, we're rounding the nearest 100,000, so we would knock off that decimal if we were rounding to the nearest person. So rounding the nearest 100,000, we'd be at 33,500,000, and that's the approximate projected population for Tokyo in the year 2000.